Welcome to this class. Today I am continuing the chapter Energy of class 9 and the subject is Science and Technology and it is taken in Unit 9. This is continuation of the previous class. Today we are going to focus on biomass energy, which is one of the renewable source of energy, and we are going to focus on it, how it can be used in our daily life. Okay, let's start. But I want to recall some of the renewable sources of energy which was taught in previous class. Let's recall the renewable sources of energy and then we'll go through biomass energy. Look at this. These are the renewable sources of energy. We made this list in last class if you remember. Solar energy, tidal energy, geothermal energy, wind energy, biomass energy, hydroelectricity and hydrogen are renewable sources of energy. Among them, today's focus is on biomass energy. We are talking about biomass energy in detail. Okay, first, what is biomass energy? Let's recall this also. What is biomass energy? The heat energy obtained from the mass of plant body and animal waste is called biomass energy. Actually, we are related to heat energy, and plant body and animal waste can be used to get heat energy, and that's why this is called biomass energy. Okay, it is available in the form of solid, just like firewood, dung cake, which are widely used in Tarai region also and in villages. Look at this. This firewood is usually collected, and throughout the year this firewood is used in kitchen in cooking food. Okay, another is this dung cake. Dung cake is also used in cooking food and to make our room warm in Tarai region. And beside this, the liquid form of biomass is alcohol. Alcohol is not given in the syllabus, that's why I don't want to go through detail of alcohol. This little understanding about the alcohol is formed by the fermentation process in which food substances are used. When there is fermentation in food substances, then alcohol forms, and alcohol has a different compound. It may be methyl alcohol, ethyl alcohol, butyl alcohol, etc. This is, if pure, then this can be used to run engine also. This is one of the type of biomass energy which is available in the form of liquid. Third is gaseous form also. We can use biomass in gaseous form also. This is biogas. We'll talk about biogas in detail later. Okay, this is the introduction of biomass energy. It is the energy which we get in the form of heat energy, and it is obtained from the plant body and animal waste. It can be obtained in the form of solid, liquid and gas. Okay, now do you know what is biomass? All these are biomass. This is straw, which is one of the important biomass. This is sawdust. This is another biomass. And this is rice husk. It is another biomass. There are many biomass. I mean to say biomass is available in different varieties. This is maize husk. This can be used as biomass to get energy. And this is the shell of coconut. All these are available in the villages. And the other also, the agricultural waste. Agricultural waste is present in the village, which we can use as source of energy. If they are dried and they are burnt, then we'll get heat energy from this agricultural waste. But there is a little problem. If we use the straw in cooking, then lot of straw is needed. I mean to say we have to feed up the straw in the stove continuously, and large volume of straw is needed to cook rice and other vegetables. So there is a problem. That's why if we get this straw in the compact form, then the same thing becomes easier. In the same way, there is another problem also. These biomass are, if directly used in kitchen and in other purpose, then lot of smoke produces, and this smoke makes the environment polluted. That's why there are two problems. huge volume of biomass is needed for cooking purpose, and there is problem of smoke also. If these two problems are shut down, then this biomass becomes very good fuel for cooking purpose and other purpose also. For this, briquettes are made. I want to introduce another name, that is briquette. Exactly what is it? What is briquette? Briquette is the compressed block of biomass material. It's very simple. Briquette is compressed block of biomass material. The same biomass is when compressed by using certain machinery, then it comes in the solid form and it reduces the volume and it is very easy to use. Now, I want to give some example. Look at this. These are some example. Sawdust briquette, wood shaving, sawdust mixture, and shredded straw briquette, shredded paper briquette, etc., etc. All these are briquette exactly. These briquettes can be used to get heat energy in cooking purpose and other purpose also. Now I want to show you a short video in which the biomass is compressed and a briquette is made which can be used to get heat energy. Look at this short video. This is the shredded paper, and shredded paper is if mixed with water and it is squeezed, then we'll get a mixture, and this mixture is if mixed with sawdust, then a little more solid mixture will get a little more solid mixture. And to give it a definite shape, a plastic bottle can be used, and at the base of the plastic bottle hole is made to drain out the water, and a plastic paper is used, and there is also hole to drain out the water. And if it is pressed, then what happens? The water content in the mixture will go out, and how much amount of water we can drain out, we have to use pressure and drain out as far as possible maximum amount of water. Now at last what we get? A solid mass, compressed solid mass. This is a briquette, and if it is dried and water percentage is made very less, then can be burnt and can be used in cooking food. This way we can make briquette, and this video gives you a little idea. It can be taken as project in your class also. Okay, now I want to talk about the types of briquette. This is one of the type of briquette. There are basically two types of briquette. One is carbonized briquette, another is non-carbonized briquette. Now what is carbonized briquette? How it appears? Look at this is carbonized briquette. It is black in color, and this is non-carbonized briquette, and its color is according to the raw material. I mean to say which raw material is used in making this non-carbonized briquette, it takes the same color. And it is a little difficult to make non-carbonized briquette because we have to apply huge amount of pressure to give it a definite shape, maybe a little circular, or maybe a cubical, or maybe other shape, but huge amount of pressure is required in making non-carbonized briquette. So it can be done by using piston press or screw press or roller press. Look at this is the diagrammatic representation of piston press, where the biomass is fed from this hopper, and when it comes out, then it comes out in the form of briquette, and it is pressed by using piston press. Here is piston. And in the same way, there is another screw press also. Biomass material is fed into it, and when screw is rotated, then it is pushed forward and it comes out in the pieces, which is actually briquette. In the same way, there is another roller press also, in which when we feed on the material in it, then it comes out being a briquette. I mean to say it is pressed by the rolling of this roller, and when it passes through the roller, then it is compressed and briquette forms. This way, non-carbonized briquettes are made by using different high pressure compressor. I mean to say compressor which produce high pressure. Okay. Now there are other methods also by which we can make carbonized briquette. This is about the non-carbonized briquette. Now I want to talk about the carbonized briquette. There are two different processes used in making carbonized briquette. I am going to present one of them. Number one, in this method of making carbonized briquette, first carbonization process is carried on the biomass. The carbonization means this is a destructive distillation process. Actually, what is done when a complex material containing compound of carbon, complex material containing compound of carbon means what kind of material? Protein, carbohydrate, fat, etc. contains carbon. If they are heated strongly in a closed vessel in the absence of air or oxygen, then it decomposes into simpler substances and the process is called destructive distillation. By the process of destructive distillation, which is carried out in the absence of oxygen, the material contained in protein, carbohydrate and fat converts to carbon. Mainly carbon is left behind and it converts to actually charcoal. A black colored powdered charcoal forms after the destructive distillation of the organic matter. And I mean to say, when charcoal is produced, it may be in a solid form and this solid can be crushed. And another process which we should use is crossing. Crossing the solids material will get powder. The powdered charcoal cannot be used directly as this briquette. Briquette is not the powder. So we have to glue the carbon powder into a definite form, I mean to say a solid form. For this purpose, binding material is used. And binding material is used. The binding material may be molasses, or it may be clay, or it may be the starch of plant. Starch of yam can also be used. The binding material, when mixed with charcoal, then we can mix this binding material with the charcoal to form this briquette. But before giving it a definite shape, we have to compress it and then only briquette forms. That's why when this mixture is compressed, then it forms briquette. A definite shape can be made. Now, at last, the briquette should be dried. Water percentage should be reduced to 5% or maybe less than 5%. Then we will have this type of briquette. This is cubical shaped briquette. It may be spherical shaped and other shape can also be formed. This way, the carbonized briquette can be made. The first process is carbonization. It is the process in which we produce charcoal and then crossing this charcoal, the powder is mixed with binding material and then we compress it and briquette is made, and after making the briquette, the same is dried and these dried briquettes can be used as a source of heat energy. This is one of the method of making carbonized briquette. Now I want to tell you another method also. This method is a little different than the first. The second method, at first the raw material is collected. Raw material may be the log of wood also, or it may be sawdust also, or it may be anything. But after the collection of the raw material, it has to be shredded or it has to be powdered by crushing. When we get the powdered or dust form of this raw material, then it has to be dried. It is dried. And after drying, the water percentage reduces to very less value, about 30 to 40%. Then it is supplied to the briquetting machine, which presses the dried material and certain shape is formed, and this is called briquetting. And after briquetting, carbonization is then done. With the help of destructive distillation process, then carbonization process is done. Okay, these are the method of making briquette. I told you two methods, in which first method carbonization was done at first, but in second method carbonization was done at last. Now, what are the uses of briquette? Why are we so interested with the briquette? What are the uses of briquette? Briquette can be used for different purpose. One is cooking food and boiling water. And another use of briquette is heating room in winter. Another use is to incubate baby chicks in poultry farm. Another use is to dry vegetable, mushroom, wool, etc. in the industries. These uses are given in your book also, that's why I'm highlighting these uses. Now, what are the advantages of briquette? Why should we prefer briquette instead of using LPG, instead of using firewood, etc.? Why should we use briquette? There must be certain advantages. The advantages are, it is renewable source of energy and available forever. Second, reduction of air pollution. If we use firewood, then lot of smoke produces which pollute the environment, but briquette doesn't pollute the environment in comparison with the firewood. Now, another is utilization of agricultural waste. Agricultural waste can be utilized very nicely in making briquette. Otherwise, waste is waste, which we cannot use again. And another, reduction of use of firewood. If we use firewood in less amount, then certainly deforestation doesn't occur. Instead of briquette, if we use firewood a lot, then lot of firewood will be consumed and deforestation takes place. That's why briquette reduces the use of firewood. New source of income for the farmer. If we make huge amount of this briquette, that can be supplied to the city area also, and we can get heat energy in different purpose in city area also. Now, let's talk about the precautions while using the briquette. How to make briquette I told you, and what are the advantages of the briquette also I told you. Now, we have to take care while handling briquette. When using briquette, what precautions should be taken? It should not be used in unventilated room. If we burn this briquette in unventilated room, then lot of carbon dioxide gas produces that becomes very harmful to the human health. That's why unventilated room should not be used when we use briquette. Now, it should be burnt in a metal container or on the brick, but not on the floor of house. If it is burnt on the floor of house, then damage may occur on the floor. Now, next is, it should be kept out of the reach of children. It is normally burnt in open place. That's why children should be away from that open place while using this briquette. Okay, this is all about the briquette. What is briquette? How briquette is made? What are the types of briquette? And what are the advantages of briquette? And what are the uses of briquette, etc., etc. I told you. Now, let's talk about another biomass, that is biogas. Exactly, what is biogas? We can define biogas this way. Gas obtained by the anaerobic decomposition of cattle dung and agricultural waste, which mainly contains methane gas, is called biogas. Look at this definition. 3 points are highlighted. First, the raw material is told agricultural waste and cattle dung are the raw material for biogas, and the process is also told anaerobic decomposition is used in making biogas. And third, it gives the gas which contains mainly what? Methane. And this way we can define biogas. But in the context of the composition only, we can define biogas this way also. Biogas is a mixture of methane, carbon dioxide, hydrogen and hydrogen sulfide. Actually, by the anaerobic decomposition of this cattle dung and agricultural waste, not only methane, carbon dioxide also produces along with hydrogen and hydrogen sulfide. The percentage of methane is about 65% and remaining is this carbon dioxide, hydrogen and hydrogen sulfide. This way we can define biogas. Okay, now biogas is produced in biogas plant. What are they? It is of two types. There are two types of biogas plant where we can produce biogas. Number one, floating gas holder type biogas plant. And number 2, fixed dome type biogas plant. But different types of biogas plant is not given in the syllabus. That's why this first I don't want to describe in detail. The second type, the diagram of this second type, fixed dome type biogas plant, is given in your book. That's why with the help of this fixed dome type biogas plant, I want to describe how biogas is made. I mean to say how biogas is produced in biogas plant. Look at this is the diagram which represents biogas plant. Here we have 3 different types of tank. One is mixing tank, another digester tank, and third is overflow tank. Biogas plant consists of 3 different tanks: mixing tank, digester tank, and overflow tank. Now certainly look at this mixing tank. Here the biomass is fed, and then the major process, destructive distillation, occurs in digester tank, and the gas produced is taken out from this outlet, and because of the huge pressure of the gas produced in this space, exhaust pressure and used biomass material is then thrown out to this overflow tank. This way it works. I want to describe in detail its working. Okay, let's make it at one side. Now first what we do, cattle dung and water are mixed in equal proportion in the mixing tank to prepare slurry, and the slurry is then fed into the digester tank. We are feeding slurry from this mixer tank to the digester tank, and then digester tank is filled with dung slurry up to the cylindrical level, but the dome is left free for the collection of biogas. This is dome shape, and this dome shaped, this part is actually not filled with this slurry till this circular area. The circular part, when it starts, then will stop to feed the slurry. And then the new gas plant takes about 50 to 60 days to become operative. It takes 50 to 60 days for destructive distillation and the production of biogas. And then what happens? Within 50 to 60 days, the cattle dung undergoes degradation by anaerobic bacteria in the presence of water with the gradual evolution of biogas. This anaerobic bacteria means the bacteria which survive in the absence of free oxygen, but in the presence of water it decomposes the biomass which contains protein, carbohydrate, fat. It decomposes them and forms mainly methane gas along with carbon dioxide, hydrogen and hydrogen sulfide. And the biogas starts collecting in the dome. In this dome part, this biogas starts collecting in the dome, and when the collection is enough, then it exerts pressure on the slurry in the digester tank. It exerts pressure in the downward direction, and this pressure forces the spent slurry. Spent slurry means which already undergoes through this anaerobic decomposition. The pressure forces the spent slurry to go into the overflow tank. This pressure of the gas pushes this remaining slurry into the this overflow tank. And what happens? The spent slurry left after the extraction of gas is removed gradually, which is rich in nitrogen and phosphorus compound, and hence forms good manure. Whatever collected in this overflow tank is actually manure, and this manure contains mainly nitrogen and phosphorus, which are very, very good fertilizer for the plant. That's why we are getting fertilizer from biogas plant also. And then once the plant becomes operative, more fresh dung slurry is added to the digester tank for continuous biogas production. If we want to get gas continuously, then slurry should be fed from this mixing tank continuously, and we'll get it for a long time without any obstruction. The biogas collected in the dome of the digester tank is taken out through outlet and used as required. This is the outlet for the biogas and can be used in cooking purpose, or it can be also used in lighting purpose, which gives us light in our room. Okay, now look at this biogas plant again. We can make this biogas plant whenever, wherever we need to make it. We can make this easy and very simple diagram to represent biogas plant. And if you are told to write, or if you are asked about the uses of biogas, then you can say it like this: it is used as a fuel for cooking food. Why should we use this biogas for cooking? Why not firewood? Why not liquefied petroleum gas? Question may be like this also. We can say this way: it burns without smoke, hence it is pollution free. That's why it can be used in cooking. It has high calorific value. High calorific value means per unit mass, when burns, per unit mass it produces huge amount of heat energy that is very helpful to cook food, and it does not leave residue after burning. So it is a clean fuel also. It does not leave any residue like ash. This firewood is if used, then ash produces. And there is no problem of storage because it is directly supplied by pipes from gas plant. We don't have to store it. It is produced in the biogas plant and directly supplied to the kitchen and rooms. We don't have to store it. And if we want less amount of biogas, then the feeding can be reduced. And if we want more amount of biogas every day, then feeding can be increased. Okay. It is cheaper than other fuel. This is actually free of cost in the villages. We are using just the animal dung as raw material and agricultural waste as a raw material. That's why it is very cheap. And it is used as a fuel to run engine. In villages, in many places, the engine of water pumping set used for irrigation utilize biogas instead of diesel. Now there is another use also. It is used to generate electricity. While generating electricity, biogas is used to boil water, and boiled water produces steam, and high speed steam is used to rotate the turbine. Turbine runs generator and generator produces electricity. This way the biogas can be used for different purpose. First, cooking purpose, and second, it can be used to run different engine, and third, it can be used to generate electricity also. Okay, there are some advantages of biogas. What are they? It burns without smoke, hence it is pollution free, and its installation cost is high, but on the long run it is cheap because its raw material is just the animal dung. At first we have to make the tank, and this tank is made up of brick, cement and sand, and that's why a little cost is used in the installation. But on the long run, what happens? We are using just the animal dung as raw materials, so it is cheap in the long run. Okay, next, it is also the source of light. When it is burned, then light also produces. That's why it can be used as a source of light. It displaces the use of firewood, so it saves the forest. And the byproduct of biogas plant is high quality fertilizer. These are the advantages of biogas. Okay. Till now, I told you a lot of matter related to biogas and some important facts about the briquette also and types of briquette also. Now it's time to talk about the question. I want to present one question. Now looking at this question, you have to analyze the question and find the correct answer for it. Statement: clay, molasses, stars of plant, etc. are used as binder in making briquette because they are the main component of briquette which bonds to produce heat energy. What do you think? This statement is correct? Think about this. Now next, argument 1. Dung cake is also a type of non-carbonized briquette formed by applying low pressure. Is it correct? Think about this. And argument 2. Non-carbonized briquette is black in color. Looking at all these statement and argument, we have to select one of the option from these four. One of the option is correct. Now let's find the correct option. What is written in number 1? Only statement is correct. Is it? Clay, molasses, starch of plant, etc. are used as binder in making briquette. Yes, this is correct, but remaining part says because they are the main component of briquette which burns to produce heat energy. This part is not correct because the major component is biomass which contains mainly carbon, and that's why we cannot say the binder is the major component. This is incorrect. So number 1 is not correct. We'll drop it. This is incorrect. Now let's see number 2. Only argument 1 is correct. Is it? Argument 1. Dung cake is also a type of non-carbonized briquette formed by applying low pressure. Yes, this is correct because dung cake is pressurized by using our palm and this low pressure, and it is dried, and this is non-carbonized briquette. And that's why this argument 1 is correct. But here only argument 1 is correct written, and that's why only we cannot say only this argument is correct. We have to see argument 2 also, then we'll come to conclude whether argument 1 only is correct or with 2 also is correct. Both the arguments are correct. Okay, look at second argument. Non-carbonized briquette is black in color. No, this is wrong because carbonized briquette is black in color. Non-carbonized briquette takes the color of its biomaterial. What material is used, it takes the same color. That's why this argument 2 is incorrect. So number 3, both the arguments are correct is not correct. This is incorrect. Now number 4, only statement is correct. Statement is previously decided. It is not correct. Statement is wrong. We decided it previously. So after all, we have to come to this point number 2. Only argument 1 is correct. Only argument 1 is correct because this dung cake is actually non-carbonized briquette which is formed by applying low pressure. Yes, we have to tick this one, second option. Okay, in the same way, let's go through some other questions also. Find the correct and incorrect arguments for the following. One argument is beside methane, biogas contains hydrogen, hydrogen sulfide and oxygen gas. This argument is correct or not? Anaerobic bacteria requires water for the anaerobic destruction. Now think about this, is correct or not? The manure collected in the overflow tank of biogas contains phosphorus and nitrogen necessary for the good growth of plant. Is it? Is correct or not? Let's just think about this. An anaerobic decomposition of animal dung takes place in the mixing tank of biogas plant. Now looking at all these, now we have to select the correct and we have to tick that, and we have to find the incorrect, we have to cross that. Okay, number 1, beside methane, biogas contains hydrogen, hydrogen sulfide and oxygen gas. Is this correct? No, not oxygen. Instead of oxygen, we have to write here carbon dioxide. But this number 1, the argument number 1 is incorrect. Anaerobic bacteria requires water for the anaerobic destruction. Yes, it requires water, and this anaerobic bacteria acts upon protein, carbohydrate and fats in the absence of oxygen but in the presence of water. That's why this argument is correct. Now next, the manure collected in the overflow tank of biogas contains phosphorus and nitrogen necessary for the good growth of plant. Yes, it contains phosphorus and nitrogen. This argument is also correct. Now, fourth one, anaerobic decomposition of animal dung takes place in the mixing tank of biogas plant. Is it? No. Actually, anaerobic decomposition takes place in the digester tank, not in the mixing tank. That's why this argument is incorrect. Okay, I told you about the briquette today. we were talking about biomass and what is biomass and what are the types of biomass, and then we entered into briquette and types of briquette, carbonized and non-carbonized briquette and their advantages also, and then we entered into biogas, method of production of biogas, etc., etc. I hope that this explanation makes you clear about the biogas and briquette. Now I want to stop this class. We'll meet in some another class with another matter. Thank you.